So this is video 2.1. This is the first video of our second unit. And this unit is going to be all about the absolute value function. So in this first video, we're going to talk about transformations of the absolute value function. So last week we finished up transformations. And last week we just had a generic f of x function. But in this unit, we're going to have a specific absolute value function. So I'm not going to go through and fill all of these things out again. The notes for absolute value functions, transformations, are identical to the notes that you took on transformations less than a week ago. So the negative sign is still a reflection. A is still a vertical stretch or compression. B is still a horizontal stretch or compression. H is still left and right. And K is still up and down. So in order to make this a shorter video for you, I'm not going to do all this again. So refer back to your notes on transformations or go back and watch the transformations video again, video 1.4, if you need me to go over A, B, H, and K again. I will, however, offer you some tangent, like number examples. It's the same process, so it's not going to take too long and hopefully isn't too drastic of a jump here. But if you notice, I have the absolute value symbols, which is what those bars are, instead of parentheses. That's the main difference here. So we have f of x plus 2 minus 3. So here, that plus 2 is inside parentheses, or inside the absolute value bars. So that's my h value. My h value moves me to the left and to the right. If you remember last week, I called it a liar. So since we have x plus 2 in parentheses, this is going to move us left 2. And then the minus 3 that's outside the bars all by itself at the very end of our equation, that's our k value, so that moves us up or down the graph. So that minus 3 is going to move us down 3. So I'm not going to actually graph these, but if we had a graph, it would take the points, takes the function, and moves it left 2 and down 3. Number 2, I have a 3, and then I have a minus 2. So the 3 is out in front of the f. So it's in front of the f being multiplied, so that makes it my a value. My a value, if it's bigger than 1, is a vertical stretch. If it's a fraction or a decimal, then it is a vertical compression. So my 3 here, 3 is in fact bigger than 1. So we have a vertical stretch by 3, or by a factor of 3 if you want to make it super long. And then we have the minus 2 that's outside the bars. It's out there all by itself. So this minus 2 is going to cause our graph to go up or down, because that's my k. And since it's minus 2, we're going to go down 2 on the graph. Okay. We have our last one here. So we have the negative sign out front of f. So to the left of f, we have a negative sign. That negative sign causes a reflection. And since it's out to the left of f, it's a reflection over the x-axis. So since we have a negative out in front of f, it's a reflection over the x-axis. Oops. What's going on? There we go. Okay. Then we have x minus 9. Let me write a little bit higher. We have x minus 9 in the absolute value bars. So that x minus 9, that minus 9 is going to move us to the right 9. So the transformation rules for absolute value are identical to the transformation rules of the generic function we did last week. The beauty of the generic function is when we do absolute value or next unit quadratics, no matter what function we're doing, these transformation rules apply. So in class, we'll refer back to our old notes, and then you can just add these few examples at the end.